Hi everyone, my name is Jenicca Poongavanan, and I'm going to talk to you about reproducibility of scientific papers in movement ecology, how we doing nowadays. This is a project that I've worked on for my master's thesis, which I defended a couple of weeks ago. So yeah, a little bit of what I've learned over the course of this project, and hope it's helpful to you. Um, So just to make sure before moving forward that we're all on the same page, I'd like to just highlight some definitions. I'll start with reproducibility. Reproducibility is defined as obtaining the same reported results of a paper when using the exact same input data and following the same computational steps or running the same analysis to obtain the exact same results at the end. It is often confused and interchangeably used with replicability, and I'd just like to highlight that it is not the same thing. Replicability is the chance of obtaining consistent results when you use a different data sets but run the same analysis. So for this talk, I'm focusing on reproducibility, and that's what I investigate. And um, yeah, so why is reproducibility important? I think first it's public trust. Lay people trust science to make decisions. Most of the time we do not and cannot conduct our own research before making decisions, but rely on scientists. I think the very simple example is COVID. I know with the vaccines we're all studying up on what kind of experiments that has been happening, and what they found before making the decision of whether or not to get the vaccine or which vaccine to get. So as simple as that. And then secondly, we have reproducibility strengthens scientific claims. Researchers should be able to generate the same results and arrive at the same conclusions, to help validate and build confidence in the theory. And then lastly, reproducibility empower growth of future research. Scientists do not have to work from scratch. They can easily save time and effort by building upon results that research findings that has already been established, and then from there develop new ones. So okay, why is reproducibility important? We figured that out. It is important. So I wanted to have a look at what is happening in the across fields, and there's a very popular survey by Nature where they um, interviewed more than 1,500 scientists, and where 52% of them actually acknowledged that there is a crisis. And at the same time, there were empirical research that showed that there is actual problems within each field of science. For example, clinical research, they only reproduce 10% of their studies, oncology 11%, psychology 36%, wildlife ecology, which is very from last year, is only 26%. So I think there's a lot of improvement that can happen there, because we're all like less than 50%. So then, what about movement ecology, which is a subfield in ecology that is really dear to me and I've always been involved. So I was like, how are we doing? It's a topic that I think at the back of my mind always taken for granted, that we are reproducible, but we actually maybe not. So I was looking for ways of how to evaluate papers in movement ecology. So game plan. So first, I needed criteria by which to evaluate papers on. So what are the criteria that make good reproducible papers? And there's a lot of guidelines out there that help us figure that out, but 6 of them that I found really spoken to me and like really felt that it leads to really good reproducibility was first the availability of data, and then code availability, the use of open source software, codes annotation, and the proper documentations that come with it, the execution of the codes themselves, and then finally the reproducibility of the results presented in the paper. So once I had this flow chart down, it was time to decide on what papers to evaluate. So I focus on behavioral pattern identification methods in movement ecology, just because they are very complex and highly computational methods. those are also methods that I'm very accustomed to. So should there be any problem within the codes or lack of interpretation, I will be able to handle that. And then also filtered by date, so papers that would have been published over the last decade, because they probably would have a higher chance of being reproducible given all the available materials that we have out there, resources to, to archive data and codes, etc. And then finally, also only pick papers that used R as a programming software, because I think R is the widest used software in ecology right now. So yeah, ultimately I had 75 papers selected, and I created a workflow by which I would be able to score those papers. So I'll go through them. First, it was availability of data. So 2 points if the data was available online quickly, 1 point if I had to request it, and none if it was never made available. Same as for codes. And then I also allocated points for use of open source software, because yes, in this case, I have picked R, but this workflow can be adapted to any other analysis that you want, any paper that you would want to evaluate. So there's other open source software out there, so this is why it's here. And then also points for code annotations, because they're very, very important. And it's also just 0 2 points, because I think it's very subjective. It depends on the level of comfort somebody has with the language. So I just decided to whether or not the annotations were there. And then the execution of the codes themselves, it ran smoothly, it was complete, 2 points. 1 point if it was partial and I had to write most of the codes, and then none if it didn't run at all. Also, the reproducibility of the results themselves, it was computed with number of results that I was able to reproduce over the total number of results presented in the paper in terms of text, paragraph, tables, and figures. And then I multiplied that by 2 so as to have everything on the same scale. And then finally, once I processed all those papers and scored them, I categorized them into 3 groups. Papers with a score of 9 and above were classified as highly reproducible. Between 4 and 9 reflected some reproducibility, and then less than 4 was considered as not reproducible. Taking a closer look at the highly reproducible paper, I used Radioplots. I thought they were fun, where each axis represents criteria that I evaluate, ranging from 0 to 2, so the scores. And then there's a total score underneath the title. I think there were occasions where in HMM 02 and 04, so first and third plot, where the codes were provided were incomplete, and therefore I wasn't able to reproduce the results to its full extent. I had to write a bunch of those codes. And at the same time, on the other hand, in the case of EMH 01, they did provide me with the code, and I was able to reproduce the entire results, but they also provided me with 5,000 lines of codes, and I had to dig in and figure out what I needed without any annotation. So it was quite a mission, but eventually got there. And then the papers reflecting some reproducibility, most of them only provided the data. The very first plot, I ran into problems with the codes. I suspect different versions of packages were used, which created a bit of a mess, but that was not well documented, so it was a little bit of a problem there. And then there are other papers that were not reproducible were, well, papers that didn't provide anything, and they were only allocated 2 points for what I had already pre-selected. So it's quite sad and concerning. I think it's really changed my view on how we do science, and I think this workflow, I'd like to come back to it just to have people maybe integrate that in their process to make sure that they're not only evaluate other papers but their own before being published, and make sure that they respect some kind of level of reproducibility, which is really, really important. So I'd just like to leave you guys with some take-home message. Science should be show me, not trust me. That's a great quote that I came across, and I think it's useful. And then probably try to score your own paper, or a paper that you like, and see how does that affect you. Thank you.